Hello my dear students and welcome to this lecture series by AKtU. I am Dr. Supriya Frelatpam, Assistant Professor in BBD ITM. I will be taking unit 3 of your environmental engineering code KCE 603. This is my 7th lecture and till now we have talked a lot about physical and chemical characteristics and bacteriological characteristics of water, and we have talked about physical characteristics of wastewater and almost completed chemical characteristics of wastewater. We have all started on BOD and but we have not still finished BOD. So, now let us come back to this. This is the same slide in my previous video, but let me continue with this. So, as I have already told you about that, when we talked about, there are two types of organic matter present in the wastewater. One is the biodegradable, means one is the biodegradable or the biologically active, means which can be degraded biologically by means of microorganisms or bacteria, and another will be non biodegradable or biologically inactive. Here we will be requiring we will require strong oxidizing agents to decompose these types of organic matter, right. So, when we talked about BOD, we are talking about only this part of the oxidizing only this part of the organic matter. Okay. So, when we talked about BOD, what we are talking about, BOD is going to be the amount of oxygen which is required to oxidize the biodegradable or the biologically active organic matter, right. So, this will give BOD, right, and both of this, right. This has to be done by chemical terms, by chemical oxidation. Both this thing will give COD or the chemical oxygen demand. So, BOD will be biodegradable and COD will be both biodegradable and non biodegradable. Okay. So, we will talk about here biochemical oxygen demand is defined as the amount of oxygen required by microorganisms, mostly bacteria, to carry out decomposition of biodegradable organic matter under aerobic conditions. Okay. So, both COD and BOD are aerobic conditions, you require aerobic conditions for it. Only difference is that BOD you are going to do it biologically and COD they are going to do it chemically, right. So, now let us continue with BOD. It is the most important test for wastewater. It is very important, like whatever wastewater they will ask you what is the BOD, any test, okay, you have to do something. The BOD of water during 5 days at 20 degree centigrade is generally taken as the standard demand and is about 68% of the total demand, and it is written as BOD 5. So, BOD with a suffix of 5, right. So, BOD of the water. So, what is the standard? Standard is BOD for 5 days at 20 degrees centigrade. BOD 5 is determined by diluting a known volume of sample of wastewater with a known volume of aerated pure water and then determining the DO of this diluted sample. So, what we will do first, you will take a sample, you will have a wastewater sample here. Then what we will do, you will dilute this and then you will take the DO of that particular thing. Then this you will take a DO and then you will keep it for 5 days in an incubator at 20 degrees centigrade. Okay. After 5 days you will take it out and again take the DO 2, right. So, you will have a DO 1 and a DO 2, the initial and the final, right. This sample is then incubated for 5 days at 20 degrees centigrade. The DO of this diluted sample is again determined after the incubation period of 5 days is over. The difference between the initial and the final DO will indicate the oxygen consumed by the COA sample in 5 days. The BOD in ppm is calculated as BOD 5 equal to initial DO minus final DO. So, initial minus final and volume of diluted sample divided by the volume of undiluted COA sample, right. So, this will give the BOD. So, what in BOD test, what actually you do is you just have to calculate 2 BOD. You have to go to the lab and determine the DO, 2 DOs, one at the starting of the experiment and another after 5 days for BOD 5. If it is for BOD 8, then you are going to do it after 8 days. You are going to determine the DO after 8. Okay. So, here. So, that is what you are going to do, right. So, BOD, so why is it like this? What actually is happening here? See, okay. So, for example, we have a wastewater here, okay. Imagine this is a wastewater. This wastewater is going to have organic matter, right, and it is also going to have a DO. So, what at the initial day, at day 0, I am going to determine the DO at, okay, let us call it DO 1, okay. Say this is this value DO 1. What will, so now this has some DO, some amount of value, and it is going to have this organic matter, okay. If you keep this after 5 days, if you keep it in incubator, right, what will happen? Wastewater is going to have some bacteria, right, you expect that, or if you do not have bacteria, you should seed it with some other wastewater sample which has bacteria, okay. So, seeding is also required for cases which do not, which are in which cases you think bacteria are not there, because without bacteria you will not be getting your BOD. So, what will happen? This in this 5 days, this organic matter is going to be degraded by those bacteria, right. So, degraded by bacteria, in a sense, what will happen? Those organic matter is going to be oxidized, right. So, oxidation in the sense that they are going to use whatever DO is going to DO is present in the wastewater, and they are going to use up this oxygen. वो लोग जो भी यहाँ पे जो ऑक्सीजन होंगे उसको वो लोग यूज़ करेंगे, क्योंकि उनको वो जो बैक्टीरिया है वो यूज़ करेंगे. यूज़ करने के बाद जो बचा हुआ DO होगा, राइट. नाउ आफ्टर 5 days you will again go and determine DO2 after 5 days, okay, in the lab. So, you will have 2 DOs, the initial DO1 and the final DO2 after 5 days, right. So, from this you can determine the amount of oxygen which has been used up, right. So, that will give up, मतलब अगर आपके पास पहले आपके पास एक पर्टिकुलर अमाउंट था DO का, उसके बाद 5 दिन के बाद वो अमाउंट कम हो गया, अगर ऑर्गेनिक मैटर प्रेजेंट होगा तो वो अमाउंट उस जो बैक्टीरिया है उसको वो लोग उसको दे आर गोइंग टू decompose that, they are going to use up that much oxygen and the oxygen amount of oxygen is going to decrease, right. तो वो आपको देगा कि कितना अमाउंट यूज़ हो चुका है. सो कितना अमाउंट यूज़ हो चुका है इसका मतलब है कि वो कितना ऑर्गेनिक मैटर प्रेजेंट था, राइट. सो दैट इज हाउ वी कैलकुलेट BOD, राइट. So, the difference between the initial and the final DO will indicate the oxygen consumed by the COS sample in 5 days. BOD in ppm is calculated as BOD 5 equal to initial DO minus final DO divided by into volume of diluted sample divided by volume of the undiluted COS sample. ओके जहाँ पे आपको पता है, आपको लगता है कि आपके पास इस वेस्ट वाटर में कोई बैक्टीरिया नहीं है या कहीं आप पर्टिकुलरली उस समय पे आपको यू हैव टू डू सीडिंग, कहीं से कहीं और वेस्ट वाटर से बाहर से लेके आना पड़ेगा जहाँ पे आपको पता है बैक्टीरिया है और उसको उसमें मिलाना पड़ेगा सो दैट सीडिंग करनी पड़ेगी सो दैट आप क्योंकि आपको यहाँ पे BOD चाहिए, मतलब बायोलॉजिकल चाहिए, यू डोंट वांट एनी केमिकल्स हियर, राइट. एक और चीज़ है, वन मोर थिंग यू हैव टू रिमेंबर इज दैट लाइट मस्ट बी एक्सक्लूडेड फ्रॉम द इंक्यूबेटर टू प्रिवेंट एल्गल ग्रोथ दैट मे प्रोवाइड ऑक्सीजन इन द बॉटल. से दैट्स व्हाट. सो फॉर एग्जांपल जो आपके BOD बॉटल होंगे, BOD बॉटल्स फॉर आर ऑफ 300 ml, जो जनरली जो मार्केट में मिलते हैं, द स्टैंडर्ड इज 300 ml का BOD का बॉटल्स मिलते हैं. दैट हैज़ टू बी स्टॉपर्ड, the water has the wastewater has to be filled till the brim stoppered and it has to be kept in an incubator and it has to be dark, उसमें light नहीं होना चाहिए, because if there is अगर algae formation, अगर algae growth हो गया, then there algae is what it is actually मतलब it's a green thing, right. So photosynthesis करके it may provide oxygen, so that we don't want that. So light must be excluded from the incubator to prevent algal growth that may produce oxygen in the water. So this is BOD. Now, there are two types of BOD. Okay. Two types of BOD in sense here we are mostly concerned with the carbonaceous BOD, but there are two stages of decomposition involved in biological oxygen demand. Okay. So, there are two stages. So, for example, what I already told you that organic matter are of two types. One will be biologically active, another will be biologically inactive. Biologically active will give BOD and biologically inactive plus biologically active दोनों मिला के it will give COD. But that biologically active wala it may be of also when you it has to, that is actually BOD, but it is divided into two stages. So, there are two stages of decomposition involved in biological oxygen demand or BOD, a carbonaceous state and a nitrogenous state. Carbonaceous stage it shows the oxidation of organic matter and it shows the additional oxidation of ammonia and nitrate. So, I think if you go for any BOD book you will find this curve, it is a very common curve, right. So, in this curve what we have? We have time in x and BOD in y. Okay. So, we generally write y for BOD. So, BOD in y and time for x. So, what we see here is that as from starting from 0, as the time increases there is this is the organic matter increases. So, what will happen? Organic matter will be degraded and there is a increase in the increase in the oxidation of organic matter, right. So, here we have BOD's increase. After a particular time it will start little bit of stagnation and then after some particular time it will start again increasing, right. So, there are two stages from OA and AC, right. So, this OA is called a carbonaceous demand or CBOD, okay, and this stage 2 is called a nitrification or a nitrogenous demand and it means it is called NBOD, right. It is actually very important and whatever BOD we have calculated from BOD 5 is actually carbonaceous BOD only, and we are majorly concerned with the carbonaceous BOD at this stage and not with the NBOD or nitrogenous BOD, that will come later when you go for higher studies of like that. Till in your BTech level COD, CBOD will be your main concern. So, what actually happens is that the carbonaceous stage or the first stage, it is also called the first stage, represents that portion of oxygen demand involved in the bacterial conversion of organic carbon to carbon dioxide. So, as the name suggests, carbonaceous BOD we are talking about organic compound carbon here. मतलब जब organic carbon को जैसे for example all organic matter is going to have a carbon, nitrogen and oxygen and all, right. So, ऑक्सीजन जो कार्बन वाला पार्ट है उसको ऑक्सीडाइज करने के लिए जितने भी ऑक्सीजन चाहिए, सो दैट विल बी द कार्बोनेशियस BOD, राइट. सो व्हाट विल हैपन, वो फर्स्ट स्टेज होगा, मतलब व्हेन इफ यू हैव if there is organic matter, they are first going to those bacteria, they are going to first attack the organic carbon and then when that is over the nitrification part will start. Okay. So, there is a gap here. Okay. So, the nitrogenous stage or the second stage represents a combined carbonaceous plus the nitrogenous demand. So, when organic nitrogen, ammonia, nitrite are converted to nitrate by bacteria, a process that also consumes DO. So, what we are doing है, जो हम अभी आपको अगर याद होगा तो हम लोगों ने बात किया था कि BOD 5 है, BOD 5, right, and then there is another called BOD ultimate. अल्टीमेट इन द सेंस दैट सी अगर या कोई भी आपके पास ऑर्गेनिक मैटर होगा वो ऑक्सीडाइज होता रहेगा, मतलब दिस इज अ कर्व व्हिच इज गोइंग टू एक्सटेंड टिल इन्फिनिटी, राइट, मतलब वो धीरे 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 स्लेट, राइट, सो दैट विल बी द अल्टीमेट, जितनी बार आपको ऑर्गेनिक मैटर आपका रहेगा उतना देर आपके पास ये चलता रहेगा एंड दिस इज गोइंग टू टेक अ रियली लॉन्ग टाइम. बट सो इन जो what happens in organic matter is that since देखो BOD के साथ क्या है कि what it's a bacterial thing, right, it's organ, it's not chemical कि आप lab में किए हो, it is not controlled by you, it's controlled by the bacteria, right, and 5 days was chosen because we thought कि ये एक ऐसा particular time है जिसमें हम लोग invest भी कर सकते हैं and it's not a long time, because you can also get BOD 20 for a 20 days also that, but we don't want to wait for that much long time to get data, right. So that is the reason why BOD 5 was chosen. Another very important reason why 5 days was chosen, because in generally 5 days you will almost get all carbonaceous BOD, not the nitrogenous parts, but because that nitrification part will start around 6, 7, 8 days and depending on the amount what type of organic matter you are having. So, till 5 you can be 100% sure that whatever you are getting is the carbonaceous BOD and there is no contribution of nitrogenous part, like till 5 you are concerned with the this part of the graph, not this part, but after as you increase the time you may also have this part that you do not want, right. So, that is the reason why. So, let us again wrap this up once more. Carbonaceous BOD and nitrogenous BOD. When you talked about BOD, there are two phases of BOD. One is the nitrogenous carbonaceous and the nitrogenous part. So, carbonaceous will show the oxidation of organic carbon or organic matter. Nitrogenous part will show this part plus the additional oxidation of ammonia and nitrite. Carbonaceous stage or the first stage, this is called the first stage, this is called the second stage, represents the portion of the oxygen demand involved in bacterial conversion of organic carbon to carbon dioxide. The nitrogenous stage or the second stage represent the combined carbonaceous plus the nitrogenous demand when organic nitrogen, ammonia and nitrate are converted to nitrate by bacteria, a process that also consumes DO. BOD 5 method measures most of carbonaceous BOD around 60 70% like that. So, what are the limitations of BOD? So, we have talked about BOD and we have told that I told you that it is one of the most important test for wastewater, but there are certain limitations to BOD, certain. What is the most important thing is that see it measures only the biodegradable organic matter, this we have already talked about, right, whichever is biodegradable we are measuring. So, you may have lots of organic matter, but say for example, you have on organic matter say 100 grams, out of this only a small part is say 10 is the biodegradable and 90 is non-biodegradable. If you are measuring through BOD, this is going to give you a very wrong data. If you just do the BOD test for this type of a sample, what you will say? You will say that there is only 10 grams of organic matter present, and you are going to be totally wrong, because actually this is 100 grams, because there is a very huge amount of non-biodegradable organic matter which is going to be present. So, BOD gives you a good idea about the biodegradable, but it is not going to give you the complete picture. The second or the most important from my point of view is that the duration of the test is very long, 5 days. So, what we will do? You will start in the morning, you will do the experiments and then after 5-6 days you will get your results, which is actually very bad, because sometimes there is a you require all your results fast, right. आपको बहुत जल्दी चाहिए होता है कभी you cannot wait for 5 days, but in BOD you are forced to wait, even though if you do experiments very quickly also, then also you have to wait for 5 days. So, if quick results are needed, it is not useful. Pre-treatment is needed if the sample contains toxic waste, obviously, because bacteria won't be able to survive when there is toxic waste. So, you first have to make sure the toxins are removed and then you can do BOD test. Nitrogen-fixing bacteria can cause interference and could give higher results. To avoid them, proper care must be taken. It is essential to have high concentration of active bacteria present in the sample. So, you should when you do BOD test, you should make sure that you have lots of active bacteria. If it is not there, you have to do seeding, right. So, since this is an a video lecture and I will not be able to give you all the equations, but there are some very important equations which you have to remember, and I think you should go and study and see the derivation of all this. But for this class I will be just giving you and talking a little bit about what is the meaning of certain terms. Right. Some important equations for BOD, and I suggest that you all of you remember this, because in AKtU I have seen the question papers and you always get 1 or 2 questions, or in fact you can say 2 or 3 problems from BOD, which is actually very important, and if you remember this you can easily solve all those equations all those problems very easily and score very good marks. So, the rate at which BOD is satisfied in any types depend on the temperature. Okay. So, there are 2 factors you have to remember for BOD, that is it is dependent on temperature and the amount and the nature of organic matter present in the sewage. So, first is the temperature, you require temperature, and another is the amount, how much is there, is it lots of organic matter are present, and what is the amount, like is it biodegradable or is it not biodegradable. Even the lots of amount of lots of organic matter are present, and if the amount of organic matter which is biodegradable is less, then obviously you will get smaller values of BOD, right. So, for this what you have to remember, at a certain temperature the rate of deoxygenation is assumed to be directly proportional to the amount of organic matter present in sewage at that time. So, rate of deoxygenation is assumed to be directly proportional to the amount of organic matter present in sewage at a time. So, you will what you have is dLT by dt equal to minus KLT. Here this is the constant, it is a constant, right. So, when you solve this, you integrate this, you will see the step in any book, you get yt equal to L open bracket 1 minus 10 to the power minus k dt close bracket, and here what is L and what is y. L is the organic matter present at the start of the BOD reaction. जब आप एक्सपेरिमेंट करने से पहले, जब आपकी स्टार्टिंग में जो आप जिसका DO मेशर करते हैं, DO1 जो मेशर करते थे आपको याद है, वो आपका वो ऑर्गेनिक मैटर जितना प्रेजेंट था वो था आपका L, राइट. सो जो ऑर्गेनिक मैटर स्टार्टिंग में जितने प्रेजेंट थे वो आपका L. ओके, व्हाट इज LT? Oxygen equivalent to the carbonaceous oxidizable organic matter present in sewage after T days from the start of BOD, from the start of oxidation. So, जब ये आपका जो BOD था, अब पहले वाले पे आपका ये राइट ऑर्गेनिक मैटर था सॉरी. सो ये जो पहले का ऑर्गेनिक मैटर था, नाउ स्टार्टिंग एट टाइम 0 यू हैव L. अगर जब ये टाइम से फॉर एग्जांपल BOD 5 के लिए टाइम T5 डेज है, उसके बाद जो ऑर्गेनिक मैटर प्रेजेंट होगा वो आपका LT होगा, राइट राइट. सो ये L स्टार्टिंग में और ये LT आफ्टर 5 डेज, राइट, आफ्टर 5 डेज और आफ्टर T डेज. ओके, व्हाट इज YT? YT इज टोटल अमाउंट ऑफ ऑर्गेनिक मैटर ऑक्सीडाइज इन T डेज, राइट. ये आपका कौन सा, ये आपका जो प्रेजेंट है अभी के अभी जो है, मतलब ये अभी से फॉर एग्जांपल ये अगर आप मान लीजिए कि आपके पास 100 मिलीग्राम पर लीटर था ऑर्गेनिक मैटर, अब ये 5 दिन के बाद आप मान लीजिए ये 80 हो गया, 80 मिलीग्राम पर लीटर हो गया. ओके, YT क्या है आपका, BOD है आपका. सो दैट इज BOD इज इसका. सो 100 माइनस 80 20 मिलीग्राम पर लीटर, ये आपका BOD है. सो प्लीज रिमेंबर इट, ये है आपका BOD. YT, T इज टाइम इन डेज, ये जो K है इट इज द रेट कांस्टेंट सिग्निफाइंग द रेट ऑफ ऑक्सीडेशन ऑफ ऑर्गेनिक मैटर. ओके, और ये KD है. नाउ ये K और ये KD में थोड़ा सा ही डिफरेंस है. Is KD is the deoxygenation constant or the BOD rate constant. Remember it, this is the BOD rate constant, it is equal to 0.434 K. Now ये KD जो है it is dependent on the temperature. So there is a temperature, there's a temperature reaction here. So what is temperature? KD at T degree centigrade will be equal to KD at 20 degree centigrade open bracket 1.047 to the power T minus 20 डिग्री. से फॉर एग्जाम्पल अगर आपको KD जो है 37 डिग्री सेंटीग्रेड में चाहिए, ठीक है, तो आपको क्या करना है, जो KD का 20 डिग्री सेंटीग्रेड का है विच यू विल गेट वैल्यूज 1.047 टू द पावर T माइनस T, हियर T कितना होगा 37 माइनस 20, राइट. सो दैट इज हाउ. So you have to remember, please remember at least ये वाला formula and this वाला formula. You will be able to solve all equations, okay, all problems. So one is YT, that is the BOD at T days will be equal to L open bracket 1 minus 10 to the power minus KDT close bracket, where KD is the deoxygenation constant or the BOD rate constant, right. KD जो है it is dependent, this the values of KD is dependent on the temperature. So KD at a particular temperature T can be calculated as KD at 20 degrees centigrade into 1.047 to the power T minus 20 degrees centigrade. With this I will wrap up this lecture. Thank you so much.